So our topic is 2.4, velocity and other rates of change. And some of the key terms for this topic are IROC, which is the instantaneous rate of change, and speed, which is the absolute value of velocity. And in order to find this, we can use these equations. So the position is just f of x. Velocity is the first derivative of position, and acceleration is the second derivative of the position graph and the derivative of the velocity graph.
Alright, so the first example problems gives you the position equation because it's just f of t. So the position equation is t squared minus 10t, and in part A it asks you for the velocity. So the velocity is the first derivative of a function, and so the first derivative of t squared minus 10t is 2t minus 10, and then it asks at what is it at t equals 4. So you substitute 4 in, and then 2 times 4 is 8, and then minus 10 is negative 2. So that means that at t equals 4, the particle's velocity is negative 2. And then in part B, it asks what the particle's acceleration is. And so the acceleration is the double derivative of position, or rather the derivative of velocity. So that means that it's 2. So when at t equals 4, the double derivative is 2, meaning that the particle's acceleration is 2.
Yeah.
Alright, so in question 2, it gives you a graph, and this is the velocity graph rather than the position. So in other words, it's the first derivative. So it asks you, when is the position increasing? So when the derivative is positive, like here, when the derivative or the velocity equation is positive, that means that the position is actually increasing. So on the graph you see where it's positive, that's 0 to 6. That's when the particle position is increasing, and the opposite is decreasing when the velocity is a negative value. So that would be the interval 6 to 8. And then it asks when is the particle at its greatest speed, and speed is the absolute value of velocity. So here the greatest value would be the absolute value of negative 4, which is just 4. And then it asks when the particle is changing direction. And when it's changing direction, that means that on a velocity graph, on the right side, it would be a different sign from the left side. So like here, at like 5, it's positive, meaning that it's increasing, and then on the other side of 6, so like 7, 8, 9, it's negative, meaning that it's decreasing. So it would be a local maximum of 6.
It asks, a rocket A has a position velocity v of t after being launched upwards from an initial height of 0 feet at a time t equals 0 seconds. The velocity of the rocket is recorded for selected values of t over the interval 0 to 80 seconds as shown in the table. So our table right here, and then the question asks to find the acceleration of rocket A over the time interval 0 to 80 and indicate units of measure. So what you do is you find the velocity of, you go here from 80 minus 0, so it would be 49 minus 5 divided by the interval 80 to 0, and so you get 44 over 80, which simplifies down to 11 over 20 feet per second.